Yeah, great that all of you are here in the afternoon. I mean, it's really hot, and now we are speaking about hot production topics. I will speak about how to bring a multi-agent LLM into production and the things, the considerations that we have to do. After Sebastian and me, Irina will tell about demand forecasting. So looking forward to this afternoon. Now, this is me. I'm the managing director of dida. So, and I will speak with Sebastian, who's over there. He will be on stage in a minute, and he will talk about the really, really technical things. So don't hesitate to ask the complicated questions that I may not be able to answer. I added a sentence about dida, but fortunately we have a conference that is quite vainly named after ourselves. So probably don't have to say too much about this. But we are building custom machine learning projects. So we've built more than 80 enterprise projects. So we know what it takes to bring things into production. Now, let's try to understand the problem. How many of you know the company N-Venn-Schroff? That's what I thought. N-Venn-Schroff is a great company and is part of N-Venn, which is a multinational. They have 11,000 employees, and they built electrical connections and protection systems. And N-Venn-Schroff is a German entity. They sit in a beautiful village, Straubenhardt, near Karlsruhe. And they have one problem, and you already see that here. They built a lot of different things, right? They built a lot of different things. They built like these metal boxes that you see on trains or train stations, or like these little things that you may know from science when you do physics experiments. So they built a lot. One thing they built is the metal things around server racks. So whenever some old man goes in front of the camera and speaks about a great infrastructure build-out, you'll hear a bottle of champagne pop in Straubenhardt somewhere, and people are very happy. Now, if you have so many products, right, you get requests. So product questions, the order status, technical documentation, so be it. And this really puts the customer service at the limit. So actually, when you asked a question, this always used to trigger a manual lookup. The person was researching several databases. They're called PIM, DAM, SAP, right? And customers, they waited for an answer. Long time, inconsistent quality. And there's actually one interesting thing. In Straubenhardt, it's not so easy to find people to employ, right? So that's a struggle they have. So when staff is leaving, there's a hole. And for them, we built a system that is called SKI, Sales Knowledge Intelligence. And it's an LLM-based system for automating customer service. So LLM, automation, and customer service is one of the main use cases that you see everywhere. And we will try to focus on the small details, the thoughts that we had when we designed and built this product. Now, this is not a chatbot problem per se. Like you think naive RAG over the docs, chat UI, this is like what we would build together in a demo. But this doesn't work. So these emails, they are interesting, they are multi-intent. So you may ask like 5 different questions. You want information from a structured database, maybe an unstructured database. Some of these facts are real-time, change in real-time. Just give you an obvious example. Order status, you ask for an order status, right? This changes every 50 minutes in the database, and we need to retrieve the actual facts. There was zero tolerance for hallucination, and this is one very problematic thing here, right? And what we have done here will be a big part of this talk. And very important, getting everybody on the same page, build up trust in AI solutions. So this was the first big AI project that the company implemented. So we sat down with the team of nVent, and we made 6 decisions before we started. The first one was we work with specialized agents. So an agent is a little program powered by an LLM that owns one data connection and one only, one intent, one agent. We want to retrieve facts. We don't want to generate facts ever. Values are passed verbatim from the source. There's a human in the loop. So we will, as you will see in a moment, we'll draft email replies. But there's always a person that reviews it and sends it, so we can earn the trust of the service employees. Database connections read only, right? This is way less dangerous. Evaluation from day one. This is also something that we do with all our project. It is integrated in our architecture from day one. We don't bolt it on in the end. And we start where it's certain, where we know the problem, right? We don't pretend to solve everything at once. We look at the requests, we classify them, we identify high volume, really easy to automate tasks, and we start with them and build a composable system that can grow with the usage. So some of these choices they do actually trade this raw autonomy that we are used to from Claude, from agents that we use with traceability and trust, which was very, very important for nVent. Now, the nVent employees, they use Salesforce, and in a minute you will see what the interface looks like, and you will also see what the service looks like that we built for them. It's integrated in the workflow of the service workers. Now, Jakob, can you write an email? Sorry, I had to make this joke. So an email is coming in. Hey, Melissa, can you give me an update about my order 1804604 and this item? Jakob, right? And what you see is there's a new tab. It's called the ski tab. The interface is kind of enforced by Salesforce. So we were limited in our choice. So you can now click on this tab. The answer is generated. I kind of slowed this down. Obviously, this is happening in the background. Dear Jacob, thank you for your inquiry. I've looked up the status of your order. This is the order. We repeat the data. We get the data from the database. We write something nice in the tone of the service employee. And the data is also surfaced. We get it from the database. And it's shown here. The source is shown so people can validate. And if we have missed something or made a mistake, right? The people have all the data that is connected to the order number here, and they can search themselves. So if it was only this, right, this would already be of great help. It would already save a lot of time. Now, we like this. Looks amazing, the answer, and we create an email. Here, you could add personal information, a little personal touch if you know the person, whatever, and send. So very simple, integrated in the workflow. What happened here, Sebastian?
Thank you. Yeah, hello everyone. Let us dive deep into the actual technical things. And since I noticed that I will speak too long if I go through every slide, I will skip this and explain everything on this slide. So an email comes in from a customer. What happens first is some action inside Salesforce. If this email is completely new and unrelated to everything, is an unrelated email, a new case will be created. if it's about something where there was an email history, actually, where there was a conversation going on between the customer and customer care, the email is associated to an existing case. So in the end, we have a case. It can have one fresh email or a whole email history. And this case, or at least the parts that we need, is sent to our ski service. Then in the second step, we have our first agent. The first agent looks at this last email with the context of the previous email history and divides this email into several inquiries. We extract them. So, for example, the customer can ask about an order status and in addition about some technical facts about a product they ordered. This can happen. Then each inquiry in the same step is categorized in a special way. I will explain that in a future slide. Then, for each inquiry, we route them to special domain agents. This is in step 3, and the domain agents, you can see them in step 4 and 5. Essentially, since we only have retrieval here, we have no write access or something like that. Essentially, the domain agents have 2 tasks. They retrieve data from a database, and they generate a little reply about the fact that was retrieved. It could, in some cases, look a bit more complicated than here, that we just retrieve once and reply. There could be more evolved strategies because there can also be some loops because the identifier for what we have to look might not be unique. But in the simplest form, we have to retrieve and reply. Then, after all inquiries were handled by these special domain agents, we collect all little replies and pass them to the last agent, step 6. This is content synthesis agent, and this agent has the responsibility to just draft a consistent email from these little special replies and add some customer care behavior, some special requirements how this email should look like. Then everything is passed back to Salesforce, where the human can review it and later send it. One thing I would like to add in this step 5, we have these additional tasks of create citations. These are at this time when the data was retrieved from the database. They are linked to the replies and they are also passed to Salesforce. So we not only send the email content, but also everything that happens before, whether something failed, how the actual citations look, and possible warnings. It can happen that something is not found, or, for example, a cross-check could be made that a customer had some order number and there was a little error, swapped 2 numbers or something like that, and the customer was actually not permitted to receive these data. And then there's also a warning, hey, little customer care person, can you look whether the customer actually is permitted to receive this answer? Okay, before we dive deep into the pipeline and everything's connected, let's have a more coarse look on the architecture, on the components of the whole system. So we start in Salesforce, and connected to Salesforce is the ski service. We explained that we sent a case and then send the reply back. In fact, it's a little bit more complicated because we want our ski service to work asynchronously. The whole task can take a minute or 2. That's too long to hold up a connection and to block everything. What happens? Salesforce sends the case to the ski service, and then ski immediately responds with an ID, with the ID of the response that is going to be generated asynchronously. And with this ID, Salesforce knows which response belongs to the case. Then ski works asynchronously. As I explained, this pipeline goes through, and once it went through, once the response has been generated, it says, well, now I'm ready. Step 3, it sends a little notification just with the ID to Salesforce, and then Salesforce, whenever it wants, can send a retrieval request to the ski service, and the ski service will answer with a generated reply. And as we saw, we have also a little feedback loop at the end. After the review, the customer care person can send feedback back to the ski service. On the other side, the ski service is connected to the information sources. Markus already mentioned we have essentially SAP, PIM, and DAM. SAP is the ERP system. PIM stands for Product Information Management, is essentially product master data, and in DAM there are documents. But in fact, nVent decided to compose all this data in one big data lake, Snowflake. So we actually access Snowflake. This is by no means necessary. We could also wire different systems to the individual agents, but this was just a choice by nVent that they wanted to have everything together. Our ski service needs its own database in order to save the generated responses, to save the human feedback and AI evaluations. I will come to that in a few slides. We have an access to an LLM. In this case, we used AWS Bedrock, which served the cloud model, and we use LangFuse for tracing, such that we can observe how the individual steps of the email and the separated inquiries and so on go through this pipeline. Okay, now the pipeline. Let's dig a bit deeper. So in the first step, as I said, we have the inquiry extraction. We have one case, we look at the last email, and we can extract several inquiries, and with the extraction, we categorize them. When we started, so the first question, of course, is which categories do we want? And we started actually by talking to nVent, and they said, well, we already have a classification, the Einstein classification, which is built in Salesforce, and they trained a classical classifier with some flat categories, for example, order status, transport status, technical request, documentation, new quote, new order, order change, and so on. So roughly a dozen categories. And this was a nice baseline and an out-of-the-box classification, but actually it was, for our problem, not suitable because it was too coarse. The classification was provided only per case, not per email, and especially not per inquiry in the email. So we thought, well, if we base everything on this classification, then everything downstream doesn't work if the email is misclassified. So we took ownership and said, well, we do something similar. We take the Einstein categories, but we apply them for inquiries. So we said, well, we want to start with these 4 categories: order status, transport status, technical requests, and documentation. These are the categories that we started to support. And then everything else is an other category. And this is the way we started before we went into the testing phase, and it went okayish. So especially the instruction part went quite well, but for the categorization part, there was room for improvement, very honestly. And why? Because of this other category. This absorbed the long tail, new quote, new order, order change, payment, and so on. And if you tell an LLM, well, choose one of these 5 categories, and first one is everything related to order status, and other is everything else, and to receive an email which is about a new order or an order change or an order cancellation, the LLM might not be able to pick the right choice because it's unsure whether to pick order status or other. And we saw this in the data, and what we ended up with is version 2. And what I did actually was resources, and I went to the person in our team which was from the customer care team, and I asked her, well, what do you do when you have a new employee? You need to explain the new employee how to label this. What are you doing? Do you have a manual or something like that? And she said, sure, let's... I can provide something. And what she provided me was an Excel sheet where this order status was explained by a definition, and in particular, it also had the definition of what to include into this category and what not. And then I did some data cleaning, forged everything into code, and this was the key to access. I put the domain knowledge into the LLM at the end, and then the classification went very, very well. Okay, next part. Once the inquiry extraction happened, everything goes to this special domain agent. I explained the main part of these domain agents already. We have retrieval and reply generation. And let's concentrate on the last part. Then everything is collected inside this content synthesis agent, which forges then everything into one email response and adds customer care behavior. And what's happening here is this content synthesis agent is following precise protocols. We want precise customer care behavior. We want content integrity, structural compliance, linguistic cohesion, and style adaptation. And what does this mean? Content integrity, for example, means that everything should be grounded by the data that we retrieved from the database, and we want complete answers and much more. Structural compliance means we have specific requirements on the structure of the email. We want, for example, that every email begins with a salutation, and the email should never end with a closing formula, because the closing formula is already contained in the customer care person's individual signature. We want plain text, we want no markdown format, and so on and so on. So very specific requirements, and these are added in this last step. So all in all, we have a very clear separation of responsibilities. We have very narrow agents. Inquiry extraction, let's analyze what to do, then do it, and then format it. Okay, let's skip this. Let's come to this citation feature. With the architecture that I just presented, hallucinations are already very, very much minimized because we gave the LLM agents very simple tasks. Still, hallucinations can happen. They can always happen. You cannot avoid them. And what we then did, in addition, was integrating a citation feature which avoids hallucinations even more. What we did is we linked every claim to its original source record and added these citations. You can see them on the right. You have the sources, you have quotations, and you have the raw feature. And you saw this in the examples that Markus showed. The quotation would be this, and the raw feature, the raw data would be on the right. And the key fact is that in the quotation part, we never paraphrasing any values that comes from the database. These data that you see here is exactly from the database. The only thing where a hallucination can happen is in the selection part, in the part that I tell the LLM, well, tell me which things did you use. And this is a rather easy task. With this task, almost no hallucinations happen. And if they happen, the customer care person can still click on the raw data, and then they will see the whole record. Okay.
Okay. I mean, obviously, as you see, lookups in database is very much reduced. And we start with the categories that we can handle immediately, 5 to 15%, depending on the business unit. We can answer now. We started with one person, Katja, who helped us to develop this tool. We need to have feedback, as Sebastian said. We rolled out to 3. We are somewhere between 15 and 30 service employees at the moment, and we will roll out to all the people working in customer service at nVent. Now, where does it go from here? We built this additive by design. So we are here. We will add these very specialized agents to expand, to answer more and more of these requests. All the agents are safe to expand, and this was there from the beginning, right? This is how we designed this. We start narrow, widen deliberately. A couple of things. So our feeling, don't know your experience with, we see that specialist agents, they beat monolith. They are just much easier to test, to route. It's much easier to trust them than a mega prompt that you don't understand anymore. Language generated, facts passed to the answer, human in the loop. So this is like very nice, actually, a very nice learning. I mean, people were skeptical. Oh, AI, what's going to happen, etc. But having people in the loop, letting them review the answers will help us. We'll find edge cases much earlier, but it also earns the trust, because in most cases this works, right? And people that review it will see that it works, and they slowly trust the system more. And eventually you can put this in the background and really automate everything. This build evaluation from day one, I can only recommend. So this will go further, we'll deepen. They use different ERPs in different countries, so we'll expand from there. We will broaden the scope, so the database connections can be connected to internal chatbots of nVent. We want to write back to the database. This is what we avoid now until we have a working system, but you can think of something, an invoice comes, you extract information, you write it to your ERP. And the end goal here is to have something that the sales team needs. The customer service is part of the sales team, like prescriptive, proactive recommendations and a lot of automation, so people really have time to focus on what they should do, selling, increasing business value. Now, we really enjoyed working with nVent. So you see here a photo of the nVent team and us that we're working on this. So if you meet the people from nVent, I can highly recommend working with them. But until then, we are very happy to answer any questions that you may have.
Yeah, thank you very much to presenting the different dimensions of this problem, and we're open for questions.
So you said this is kind of a pilot in production since March. So I'm interested, what did you learn in this time? Since it's running in production, what are the typical errors or maybe repetitive errors that LLM made? Did you correct something since then?
Thank you to answer this.
Yeah, so the main errors that occurred immediately after the test phase were this error with the misclassification. So, and since then, I would say it's rather stable. So the feedback is rather positive. Yeah.
Yeah, hi. Thank you for the presentation. So I have a question regarding the content that you use, like the style format or the information you provide with your answer. How do you store this content? Is it in JSON? Is it the human readable version of a SOP that's put in in the back end, or how do you make sure, so where you find the information, do you structure the text in a specific format to make sure that that it will be retrieved exactly as it's meant to be retrieved?
So you mean the structuring of the final email? Did I understand?
Not the email, the content that helps create the email. So if, for example, if the question is, I have a technical question, then you need to search into the technical database to provide the right answer.
Yeah.
How is the content behind?
Yeah, we are linearizing it to a string. So it's structural data. We retrieve it from the database. So essentially key value pairs. You have the attribute names, attribute values. Sometimes it can also be nested, and then you linearize it to a string. So, for example, just similar than we saw in the example here. Yeah. So this is precisely how it can look like. Order number is this number, order date is this date, and so on. Yes.
So very nice presentation, first of all. And my question is, as you mentioned that specialized agents work better than monolithic. Do you have any example or any quantification of metric that you say, okay, earlier we used monolithic and we were getting much higher throughput. However, the model was hallucinating a lot. And then we switched to specialized agent. And however, because it's a stack of agents, there are multiple agents involved. The throughput was lower or latency was higher, but we were able to reduce hallucination by XX%. Do you have any quantification of that, or by your experience, what do you want to say on that? Thank you.
I don't have a quantification from this project. Do you know one?
No, we actually don't have a quantification, but I think some things are very difficult to deal with, like passing the values in a monolithic large, I call it mega prompt. It's not so easy, so it's very, very difficult to compare. But obviously, we are still running evaluation, seeing how many % of mistakes we are making, and that's an ongoing process before we move to the next step.
Yeah, okay, switch. So how much, sorry that you used LangGraph, how much liberty or freedom did you settle on in the end for the agent? Did you give them just full freedom to loop as much as they want, or did you provide them very specific tools to sort of aid with the retrieval?
Very little, actually. So actually it's the orchestrator, so the pipelines that we can see, for example, here is not written in LangGraph, so it's plain Python. And the specialized agents, they are either using LangChain or LangGraph. But even within LangGraph, I guess it's mostly one tool. Jakob, you used LangGraph, right, for one implementation, and it was one tool, right? Okay, so very, very little liberation.
Thanks for the talk. I'm curious in the direction of long-term use of this case. For example, so what are the models, what are the LLMs that are behind right now? In the future, what if these LLMs go obsolete or new LLMs come? And or the cost of whatever the LLMs being used increase. I guess this maybe is also a question to the company that you have built this for, but what would happen, or generally what kind of burden the company may face in the future in terms of cost, change in the background model, or even in terms of, for example, whatever the specialization that you have built, which is working very good for this LLM that you are using right now. What if it doesn't work for another LLM agent, the LLM in the future, or is that a possibility?
Yeah. So 2 points. First, switching the LLM is no problem at all. I mean, it's LangChain, it's a base model, I guess it's the abstract base class, and you can just plug in another one. So whole architecture is built with a dependency injection, and you just on the very outer level, you plug in another LLM. So from a development point of view, it's trivial. From an operational point of view, I actually skipped these slides. We have also built an automatic evaluation, which measures the quality of the agents by an LLM-as-a-Judge technique. A judge is just an agent that creates another agent. And so this can be observed. So if the LLM exchange, if we switch it to another version and it would degrade the performance, we can always roll back. So, and we can observe it. So.
Hello, thank you for the presentation. I would be curious about what performance difference you saw maybe in using different LLMs. Like, did you see? So my intuition here is like they are pretty much maxed out the quality on this task for a while. Maybe, I don't know. Is that something that you see, that maybe using, let's say, latest LLMs or the biggest one, or even like a smaller version like Gemini Flash or something, maybe they would perform basically all very well?
Yeah.
Could you tell a little bit about it's just generally what you observed in terms of performance in different models?
Actually, we didn't exchange a model during the project so far at all. And my general experience with these models is they all work very well if you design the architecture very well. So, modern LLMs just work well. Thanks.
Hello, and thank you for the talk. I saw on one slide that you're using LLM-as-a-Judge, and I'm wondering how you design the task for that judge and how you keep that task from growing into a monolith.
Yeah, I mean, it's a very simple data structure. You have a task, it's just a data model, and it carries protocols. These are the criteria that the agent should fulfill, and then you have to tell the model what this means. You have to linearize each criterion to a little prompt snippet. And that's what we actually did. And the judge is coupled via these very same criteria. The criteria here are called standards because these are the criteria that don't say what the judge should do, but what it should assess. And a judge can go through criteria by criteria and this way evaluate. Thanks. You see that actually in this example on the right here. On the other slide, I talked about content integrity, structural compliance. This is exactly the example here, and the evaluation would work in this way. The judge looks at these leaf criteria. For example, factual grounding is everything based on what we retrieved from the database. Yes, check. Boolean value is true. Response completeness. Well, in this case, the customer asked for a tracking link. It's not there, then it's false. And this way you can, of course, by aggregating this, derive a total score. If you do it binary, in this case, if one thing fails, then the whole evaluation fails. So then the score would be 0, but you can, of course, think of other metrics. You can, for example, here you can count this as 1/2. This is 0, then you have 1/2. Here you have 1, and then you compute a weighted score, for example. So there are different ways to evaluate this